In this bite-sized video, we focus on two logic gates, the OR and the NOR gate. Both have at least two inputs and one output. The OR gate implements logical disjunction. Take a look at the truth table. Logical 0 on the output appears only if all of the inputs are zeros as well. Otherwise, the output is 1. In other words, if any input is set to 1, the output is 1 irrespectively of all the other inputs. The NOR gate, similarly to the NAND gate in respect to the AND, is the inverted version of the OR gate. If you look at the symbols, you will notice the same difference as before, which is the negation at the NOR output marked by the little circle. We will find the OR gates in this 7432 chip, the NOR ones in 7402. Both chips have 4 2-input gates. At this point, you may be used to the layout where the first gate has its inputs on pins 1 and 2 and the output on pin 3. And this is true for the 7432 as well. However, for some reason, the 7402 has its gates turned over. The output is on pin 1 and the inputs are on pins 2 and 3. Remember about this and refer to the datasheet if unsure. That is also the reason why I switched over those LEDs for the NOR gates. The output is on pin 1, 2 and 3 are inputs. So currently we have zeros on both inputs, and as expected, the OR gate produces 0 at its output and NOR gate produces 1. Now, if you remember the truth table, if we switch any of the inputs to 1, the output of the OR gate should switch to 1 as well, what you can see now, and obviously NOR gate, which is a negated version, will turn its output to 0, and we can switch another input which doesn't change the output, and as long as any of the inputs is driven with 1, the output stays 1, otherwise it is 0. Of course, I'm talking about the OR gate, the NOR is always negated. In the Intel 8086 assembler, we can use the OR instruction to do bitwise OR. In C or C++ and the similar, there is the double vertical bar operator to do logical OR and the single vertical bar to do the bitwise OR. In programming, we use OR to set specific bits in a data. For each one in the second operand, the corresponding bit in the data is set irrespectively of its original value. All the other bits in the data stay unchanged. That's it for today. Thank you for watching, and I hope to see you soon.